Artificial intelligence is a major field within computer science that concentrates on creating systems capable of displaying intelligent behavior in an automated way. This field is not limited to machines alone, but is inspired by intelligence as it appears in many forms across existence, including humans, animals, and even living biological systems. Intelligence can therefore be understood as a universal phenomenon rather than a purely human trait. At its core, intelligence can be described as a continuous process that begins with perception, followed by analysis, and ends with reaction. An intelligent entity first perceives information from its environment, then interprets and evaluates that information, and finally produces an appropriate response. This cycle is repeated constantly, allowing the entity to survive, learn, and improve its interaction with the surrounding world. One common way to understand intelligence is as the ability to acquire knowledge or to gain benefit from experience. Through repeated exposure to situations, an intelligent system becomes better at handling similar conditions in the future. Learning from past events is therefore a fundamental element of intelligence and a key objective in artificial intelligence research. Intelligence is also strongly associated with the capacity to adapt. An intelligent being can adjust itself effectively when faced with new or unfamiliar circumstances. This adjustment does not rely solely on pre-existing rules, but on flexible reasoning and the ability to modify behavior according to changing conditions. Such adaptability is essential in real-world environments where uncertainty is always present. Another important perspective views intelligence as the ability to acquire or develop the skills needed to adapt to one's surroundings. From this viewpoint, intelligence is not a fixed quantity, but a potential that grows over time. An entity is considered intelligent to the extent that it can learn, evolve, and improve its responses to environmental demands. Finally, intelligence can be defined as the capacity to confront and solve novel problems. The presence of new challenges requires creativity, reasoning, and the integration of prior knowledge to generate effective solutions. This problem-solving ability is central to both natural intelligence and artificial intelligence and represents one of the ultimate goals of intelligent systems development. Artificial intelligence is commonly described as a field of computer science dedicated to building systems that demonstrate intelligent behavior. Such systems are expected to understand aspects of human behavior process, natural language, reason about situations, and solve problems in a purposeful manner. Researchers approach this field from different perspectives. Some aim to replicate human cognition as closely as possible, seeking to model how humans think, learn, and decide. Others focus on creating intelligence without tying it to human characteristics, emphasizing functionality, efficiency, and performance rather than similarity to human thought. A further perspective views artificial intelligence primarily as a tool for serving human needs and improving comfort, productivity, and quality of life without requiring a strict definition of intelligence itself. These differing goals are not contradictory. Each approach contributes valuable ideas, methods, and insights that help advance the field. The diversity of viewpoints has allowed artificial intelligence research to expand into many directions and applications. However, the absence of a precise and universally accepted definition of artificial intelligence creates conceptual challenges. Without a clear definition, it becomes difficult to determine the true limits of artificial intelligence and to evaluate what goals are realistically achievable. This uncertainty highlights the importance of first establishing a foundational concept of intelligence before attempting to design or assess intelligence systems. One important distinction in artificial intelligence research lies between optimal reasoning or behavior and human-like reasoning or behavior. Optimal reasoning or behavior refers to systems designed to act in the most efficient and effective way possible based on logical principles, mathematical models, and objective performance measures. Such systems may not think in the same way humans do, but they aim to achieve the best possible outcome given available information. Human-like reasoning or behavior, on the other hand, attempts to imitate the way humans think, perceive, make decisions, and sometimes even make mistakes. This approach values similarity to human cognitive processes, even if those processes are not always optimal. Artificial intelligence encompasses several major domains. These include problem solving and search, which focus on finding solutions within large spaces of possibilities. Knowledge representation and reasoning, which deal with storing information about the world and drawing conclusions from it. Machine learning, which enables systems to learn from data and improve over time. Natural language processing, which allows machines to understand and generate human language computer vision, which focuses on interpreting visual information from images and videos. Robotics, which integrates perception, reasoning, and action to interact with the physical world. Expert systems, which emulate the decision-making abilities of human specialists, and intelligent agents, which act autonomously within an environment to achieve specific goals. For an intelligent system to successfully address a specific problem, the problem itself must have certain attributes. The problem should be clearly defined with identifiable goals, constraints, and success criteria. The environment in which the problem exists may be fully observable or partially observable, and the system must be able to perceive relevant information. Actions available to the system should be definable and lead to predictable or learnable outcomes. The problem may involve uncertainty, complexity, and change, requiring the system to adapt and to learn over time. Finally, the problem should allow for evaluation so that the effectiveness of the intelligent system can be measured and improved.